So in order to understand the universe and know what's in it, we have to interpret that information and ultimately understand what gravity and light are. So in the furthest reaches of the science of the book, we actually get to the deepest issues that still face the scientists, which is how to integrate an understanding of gravity and light. Because ultimately, all our scientific descriptions encompass more and more phenomena. So if we ever feel that there is a theory of everything, which many scientists believe that we may one day have, then we have to understand how at the beginning of the universe, how the patch of radiation that expanded, that is the universe that we're in, as we see it 13.7 billion years later, how when it began, the four forces of nature, how they're actually related to each other, how they're integrated as one force. So it's all about unification.
How did you as a writer respond to the challenge of making these cutting-edge theories, which often require advanced science and advanced mathematics that may be mutually incomprehensible to practitioners? How do you begin as a writer to try to convey some of those ideas to the layperson?
Well, initially I wrote a proposal for the book that had no bearing on the finished book at all. I think I was quite fearful of writing a book. I didn't even know whether I could write a sort of joined-up narrative of anything. So I had this sort of idea of timelines and space lines, and I'd have sort of objects hanging from them, and I'd write little notes about them. And then I quickly realised that that wasn't going to work. And I actually spent a couple of years just absorbing myself in the material and doing a lot of reading and thinking about how I might be able to structure the book. And once I actually knew how to tell the story, then oddly enough, it didn't take that long. You know, my fear every day of thinking, well, actually, am I a writer? Do I know how to write? Sort of disappeared once I was doing it each day and I knew where I was going. And once I knew where I was going, then I could find particular texts that were going to help me answer the questions that I knew I needed to answer, or I could allow myself to think about them until I knew that I knew. And it turned out that the internet is a huge resource when you actually know what the question is that you want to answer, and I don't think I could have done it without the internet. I think it would have taken about 10 years longer if I hadn't been able to find these incredible sites like NASA has on particle physics or whatever. You know, there's some incredible stuff out there.
I was particularly taken with your chapter on the origins of life, the conditions in which life on Earth evolved, and the scientists' speculation about the possibility of life on other planets. And I was particularly taken by the contingency, really, it seems, of life. The odds seem to be stacked against life originating on Earth. And I didn't realise that the moon played such a critical part in that. I mean, can you say a little about those sort of particular circumstances which mean that we are here?
Well, in a way, the story of the universe is very simple. It's about evolution. It's about a patch of radiation that evolves and then becomes things with mass that come together under gravity and create stars that burn and form heavy metals and blow up, and there are simple compounds. But I suppose the big question is, well, how much life is there in the universe? How special do the conditions need to be in order for life to appear? Well, already you can begin to see that, well, you need several life cycles of stars, for example, because if you're going to have life based on heavy metals, then that's where they come from. So that immediately tells you need a certain number of billion years. But then as the story progresses and we look at the conditions, because in order to work out whether there is life anywhere else, we have to have some deep understanding of what life is here and what it looks like and what's special about it, in order then to go and look for it elsewhere. Which is why only recently have we been able to find other systems that have planets as large as Jupiter in it, because we haven't been able to see planets that small before. And now, a few years even beyond that, we're almost beginning to be able to find planets the size of Earth out there. And once we begin to see those, then we can look for other things that might turn out that there are comparable places like Earth. But there are an immense number of things that make life seem improbable. I mean, Jupiter's one of them, but then we're finding, because the size of Jupiter actually prevents massive objects from bumping into Earth and actually destroying our atmosphere and sort of effectively making life have to start again the whole time. Well, we know there are lots of other solar systems with Jupiters in, so that solves that issue slightly, except you're always then reducing the number of possibilities where life can be. But then the moon, we're very lucky that we only have one moon, and that it's of this particular size, because if we had several moons, there'd be these incredible gravitational tides that would cause all sorts of havoc with the stability of the Earth. But the moon is just at the right sort of size and distance that it can stabilize our orbit and stop the Earth from flipping around on its axis, which would be very disturbing to life. Then the presence of water, which is one of the things I suppose we all know of, that we're always looking for water in other parts of the universe, because the Earth is the only place we know of so far in the universe where water exists in its all three of its possible states: ice, liquid water, and steam, water vapor. And water is absolutely crucial to life, because water, not only is we're made mostly of water, but actually in an inorganic way, water is the sort of oil of the tectonic plates, and the tectonic plates wouldn't move if there wasn't water. And if the tectonic plates didn't create volcanoes and ridges and spew out gases into the Earth, there wouldn't be an atmosphere. And if there wasn't an atmosphere, life wouldn't be possible. And if there wasn't an atmosphere with the amounts of carbon dioxide in it that require the Earth to be warm enough, then life wouldn't have been possible either. And though, of course, now we're worried that we're going to make it too warm through our own interference in these incredibly intimate cycles of connectivity between the organic and inorganic landscapes, that we now begin to think, well, perhaps there isn't really a distinction between the organic and the inorganic in quite the way we had thought before, which I suppose we owe to Lovelock and this idea of sort of Gaia.
You mentioned at the beginning that spiritual questions were on your mind, and that much is clear from reading the book. And I wondered what place you felt there was for God in at least asking these questions, even if not answering them.
Well, I think there's plenty of room for God. I feel like I'm skeptical in the broadest sense possible, because I'm skeptical of materialism, because I'm not one of those people that think that if we just wait long enough we'll get a material answer to everything. I think materialism is a sort of methodology that we apply to the outside world, and what we get back is what we call the material world. But to say that the material world will ultimately be everything is quite a leap of faith, and not one I'm really prepared to make. And in any case, the material world may look very peculiar and very different from what it is now, and may encompass other thoughts of other methods of truth-seeking. So why not acknowledge those now? They may absolutely aid us in how we move forward as scientists. So I would say there was plenty of room for God, and not just in the starting conditions.
You mentioned towards the end of the book the sort of possibility of the sort of convergence of different sort of truths, the scientific truth and the truth of the theologians and the truth of the artist, that there may in some future moment be some kind of convergence between them.
We probably think traditionally of science as though you go out there and you make a measurement of something that seems to be happening out there, and then you have a theory about it which is underpinned by mathematics, and out of that comes technology, and you make finer measuring instruments, and you're in this sort of loop. But actually a lot of science progresses by insight, and also the mathematics that underpins science, which is one of the greatest mysteries of all, why actually mathematics is something that underpins our description of reality, why it works, is deeply connected to poetry. I mean, all the words that we use to apply to poetry, you could just as well apply to mathematics: elegance, beauty, and pattern seeking is one of the is as true in aesthetics as it is in science. That's what science does. It looks for connections and patterns And it's hard to know where insight comes from, because if you're having an insight before you've actually got your theory to describe it, well, where does the insight come from? There must be some other way that is almost like where poetry comes from, that is also true of science. Science is different because it has its own definition of what progress is, and it's so successful in what it does that we often don't think we need to ask, well, what actually is it doing? And so I think sometimes there's a confusion between its methodology and what it actually finds out about the world. We tend not to make the separation.